Hi everyone, I'm Alexandra and we are the solar division of Schneider Electric. Thank you for joining us for the webinar today on best practices for our XW Pro multi-unit system solutions, advanced level.
Thank you for that introduction, Alexandra. Hi, everyone. My name is Babaji Dogonlisi, like you mentioned, and you may know me already. For those who don't know me, I am the solution application engineer for solar business in Schneider Electric across EMEA and the APAC regions. So today's webinar is going to be fairly short. It was gotten from feedback from what we asked the audience, what we asked you. And we noticed some people didn't really quite have its pegged down on how to install multiple units of the XW Pros together. So we just made this short webinar to tell you the critical things to really look out for in terms of your hardware installation and also how to commission the system properly over software. So without further ado, let me start this. All right, so just jumping right into it, let's start off with the hardware because you definitely have to have your equipment, the physical equipment set up correctly before you can transition to the software side of things. So for the hardware, a couple things to look out for. I would majorly be talking about the hardware parts on the communication. So I'm talking about your communication cables here, how to set it up, what to connect and what not to connect, basically. The power cables, you would most probably, again, this is an advanced level. So you would already pretty much know a lot about how to do your power cables, the right wire gauge, the right sizing, your AC cables, your DC cables, all of those. So I'm not really going to be talking about that. But when it comes to the communication side, let's talk about, first of all, the network cables to be used. So you all on this call, I would imagine you know we have our inverter speaking ZAN bus communication network, or rather our battery storage devices speaking ZAN bus communication. So for this ZAN bus communication, if you look at the bottom of the inverter, which is what this slide is depicting, let me go back here and put on my laser pointer. So at the bottom of the inverter, once you look under it or once you just flip it, you're going to see this portion here. And this is basically your communication ports of the entire system. You have your AC sync ports, you have your ZAN bus ports, you have your battery temperature sensor ports, and then to the right, which is just a little bit cut out, you have your auxiliary ports. For now, we're going to majorly be focusing on the AC synchronization ports and then on the ZAN bus ports. So first and foremost, the cables to use here are your mentioned here, your straight category 5, 5E, or 6 cables with RJ45 heads. And yes, a lot of people might want to get the site and cut it to the right size to know exactly the length you're going to use, then crimp it manually with the RJ45 heads. But please, 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 and please do not do this. ZAN bus is a very sensitive network, I would say. It's not like your typical Modbus network where you're just using your D positive, D negative, and then ground in most cases. Here, most of those communication cables, or most of those communication strand minute cables are used, and some of them are even transmitting power over the system. So if you do not do this properly, you could have a short, you could have another issue happening. And I've seen this actually happen in real life. The issue might not happen then and there. You think you've done a good job. Later along the line, maybe like a month later, a year later, a couple years later, you start seeing a lot of nuisance errors, F66, F69. If you've seen these errors pop up on the screen of the inverter or through your inside local device, you know exactly what I'm talking about, and it can be very annoying. So we advise our customers to use factory crimped cables, and it's not like you have to go to the factory to buy these cables. You can just walk into any store and then buy these already crimped from the factory. So just know the distances you're going to really get and use them. Then for your ZAN cables, also make sure the distances you use between each, the minimum distance between each, the minimum distance for each ZAN cable you use is a minimum of 1.5 meters. This has to do with the resistance in terms of the communication also, because that was also factored into the design of ZAN communication. So don't get any cable less than 1.5 meters. It should be higher than 1.5 meters. Then across the entire ZAN network. So let's assume you have one inverter, you have two charge controllers, you have the AGS, you have the inside local device. Across the entire ZANBUS network, even if you're going to have more inverters, more charge controllers, or more other accessories, the entire distance should not exceed 40 meters, because there's also a tolerance. There's a minimal tolerance, which is 1.5, and there's a maximum tolerance, which is 40 meters. Then AC sync and ZANBUS port. So I'll explain this briefly before I come to this other line here. For your ZANBUS ports, that is where you're really going to connect all your equipment together. So from the inverters to the charge controllers to the accessories to literally every other thing. Everything is speaking ZANBUS. So everything has to see one another for there to be proper communication. Now the AC sync ports are only peculiar to the inverters, to the XW Pro inverters, I would say. You might see this on the Legacy XW Plus, on the Legacy XW also, but it's basically for the same function, for stability. You have two inverters, you have three inverters, you have a whole lot of inverters on that same network feeding the same load. You have to make sure that the system all starts together at the same time. And when I'm talking about starting together, I'm talking about the sinusoidal function. If you remember your AC synchronization, your AC sync graph, the one that simply goes up, down like a sinusoidal wave, this is where the AC sync function is really going to come in handy here. Because if they don't start together at the same time from 0 to 230 back to 0, then negative 230, you're going to have a lot of very weird voltages across the network and it could end up damaging your load. So the AC sync is to help with extra stability of this multi-unit system. So do not mix ZAN bus ports with the AC sync ports. Make sure you have your cables properly tagged to know ZAN bus is going to ZAN bus, AC sync is going to AC sync, because if you interchange them, a lot of issues would happen to the system, which is what we're trying to avoid. So make sure they're properly tagged and you won't have any issues there whatsoever. One other thing is with your terminators. So with your terminators, this little black things are seen here. Some people see them in their devices and say, what am I doing with this, and throw it away. Keep those, they are very important. So a terminator is basically a device used to show the system where you're starting and where you're stopping on your communication line, not on your AC synchronization line. Because I've seen some people install terminators on the AC sync ports. You have two here, it's everything is daisy chained. So you have, let's assume you have two inverters. So from inverter number one to inverter number two, you're going to only make use of one of the AC synchronization ports. The other ports are going to be left open. You're not going to put anything there. If you have three inverters, from one of the AC sync ports of the first inverter to the second inverter, then the other ports of the second inverter to the third inverter. So one port in on inverter number one, and then another port on inverter number three are going to be left open. And it doesn't matter which one you're starting from. It doesn't matter if I start from the one at the bottom, start from the one at the top, it literally doesn't matter. But just make sure for your AC synchronization ports, you do not put any terminators there. The terminators are only meant to be for your ZAN bus ports. And if you're using the Insight facility in the system, just like what we have here, you are going to have to put a terminator at the channel you're using. So you're starting with, let's say, the previously SCP that we had. So every ZAN bus device has two ZAN bus ports. So at one ZAN bus port where you're starting the sequence, you put a terminator, goes from a daisy chains to the other accessories, to the other equipment, then it goes to the final device. And in this case, it's going to be the Insight facility. So at the open port of the Insight facility, on the channel you're using there, you're going to put a terminator to signify where you're starting and stopping the network. Again, only for communication, which is your terminators, not for the AC sync. So now, heading over to the software side of the system. Now that you know more and in detail about the hardware communication side of the system, let's transition to the software side. So for the software side, as soon as you log into your Insight local device, so first and foremost, you have to log in under your admin privileges. From our previous webinars, you'd know how to log into the Insight local device. There are three different credentials: admin, guest, and user. To make changes onto the system, you have to make sure you are logged in as the admin. So as soon as you log onto the admin, you have your user interface on your dashboard. Click on the devices tab because that's where you're really going to start making all this magic happen to commission the system properly. From there, you have your different views. You have your device overview, inverter chargers, other devices. If you want to just streamline your view to so that you only see the inverters and you're not bombarded with all the other equipment on the network, you can just select this inverter chargers. Then you have all the inverters connected on the system. Typically, once you have this connected, was a live system, so you see everything online and everything happening very fine. If you do this properly, you'd see that everything would actually be on a fault code. It will be F66 or F69. That is because for brand new inverters, once you have it connected over ZAN bus, over AC sync, and you power it on with only DC power. So this goes back to our commissioning steps. You have to make sure you know your commissioning steps, how to start off commissioning your system step by step. So you start off with only DC power. You don't introduce any AC to the network, and then you'll see the F66, F69 because you have to change the inverter phase orientation, the unit configuration, sorry. Typically, by default, is going to be each of them are going to be set to single phase master. So you have to change this to either three phase line one master, like you see here, three phase line two master, three phase line three master. Or if it's a single phase installation, this could be your single phase line one master. This could be your single phase line slave, your single phase line slave again. This, I would say, is also a very critical moment for you to know your AC output voltages because you have to do some sort of calibration if it's not done already. With the older units, the XW pluses, you had to use the configuration tool. Some people might know that, some people might not know that. But this was a device that lets you connect to the system and then you program the output voltage you want in the system. So let's say you have 230 volts here, you have, like, we're seeing complete different voltages here. But this would have been an issue if we had six inverters. So let's say our inverters on line one. So we had the three phase line one master being 230 volts. Then we had the three phase line one slave being 219 volts. If we didn't calibrate those output voltages, we'll see that instead of inverter one and inverter 2 collaborating together to supply the load, inverter 1 is going to try and backfeed power back to inverter 2 because the voltages are way off and inverter 1 is in fact seeing inverter 2 as a load. So you'd have to do that sort of calibration, which is a very important step for you to see here. Remember, all your AC breakers are left open because you don't want any power to combine here. You're just doing your initial calibration. So with the XW Pro, this calibration will still need to be done, but with the coming upgrades we're having on our inverters on Insight Local, this is going to be more automatic. But just critically make sure, because this is a big issue for people that don't know, that you do this output calibration. Again, if you want to know more about this, how to do this, go to our technical publication website, and then you'll be able to see the steps to carry out on this. Yeah, okay. So after selecting the inverter chargers, you have to put the system in standby mode. Whenever you're making any change whatsoever to the inverter, make sure it is on standby mode. So click here on standby here, and then you can click on any one of these inverters to select to configure that particular unit. It's going to be a step-by-step process. So once you finish with the first one, you go to the second one, then the third one. Now, once you go there, you select that inverter, go to configuration, and then click on the advanced view. The basic view would not let you tweak all the settings that need to be tweaked for this kind of installation or for this kind of setup. So make sure you select your advanced view. And then from your advanced view, you transition to your multi-unit configuration. Again, at this time, it would be a good time to check the firmware of the system. Once you have multiple units of the same references together in an installation, you have to make sure that they are on the same firmware. So let's assume I have a bunch of inverters. Let's say I have 6 inverters, I have 3 inverters, I have 2 inverters. As long as they're going to be connected together for the same load, I have to make sure that they are on the same firmware And to even make things easier for you, just make sure that they are on the latest firmware to take care of old bugs that have been in the system. So make sure that is possible. Again, when I say the same equipment, this would also apply to your chart controllers. Let's say I have 4 units of the MPPT 100-600. Make sure that they are all on the same firmware. So again, coming back here, so click on multi-unit installation, and then you can see the list of different unit configurations to choose from. So now, am I using a three-phase system? Is it a single-phase system? So then you have to determine which one you want to be your master, which one you want to be your slave. This would relate to the physical devices you have there. So what we have typically applicable now are for the single phase standalone if it's just a single inverter, single phase master, and single phase slave if you want to have multiple units in single phase. Split phase, this typically applies to the inverters in the UL market, in the North American market that use different kind of operations. So for the IC market, don't bother about this. Two-phase systems, do not bother about this right now because we are currently focusing on single-phase systems and three-phase systems. So two-phase systems would not apply. For your three-phase systems, it could be your three-phase phase one master, phase two master, phase three master. Then again, like I mentioned, if you have 6 inverters into the system, there are going to be 2 inverters per phase. So you're going to have your phase one master, your phase one slave, phase two master, phase two slave, phase three master, phase three slave. Then also, after you've done all that, you're not completely done yet. Come to the scroll down a little bit more, then come to device identification. Now, each inverter must have a unique device number. Now, default, they're all going to come as 00000, but you have to change it to 1, 2, 3, 4, 5, 6. Just make sure that they're all unique because you could have done all the settings correctly, but if you still leave this as the default device numbers which come as 0, you're still going to have your F66, F69 errors. Everything must be unique. For the device instance is not so critical. You can change if you want to, but the critical one to change is your device number. Then as we're using the XW Pros, you come to the setup tab, click on configuration, then you have to make sure you put in your region code where you're using this in. The password, if you follow the commissioning guide that we have online, everything will be laid easy for you. But just as a quick tip, I mean, the password is XW Pro Grid Codes. In this caps application that you're seeing, XW capital, I will change this. The P is supposed to be small, so I will change this before I send this over to you. But you have to input this password, and then you select your region code. So if you're in Australia, you select the Australian grid code. For the IEC, if you're in the IEC region and your region isn't specifically input onto our program yet, we also have the IEC 61727 230 volts. We have the EN 50549, and we have some other codes for the UL market. So you just select which one is applicable to you at that instance, apply, and make sure it sticks. If this isn't done, you're also going to have some very weird behavior with the system. So critically, make sure you put in the right region code. So now, after all of this, you're basically done. You come back to the devices tab, put the system on operating. Once the system comes on and then everything is functioning fine, put it back to standby immediately. Wait for about 2 seconds. Do not do anything here. Then change it back to operating. And the reason you're doing this extra level of standby operating is to make sure that the settings stick. So if you do not do this extra step, you just put the system back on operating and then you go on with your day. Those settings you have just changed from commissioning each and every one of your units might not stick in the system. So let's say something happens and then there's some downtime with the inverters. You put it off, put it back on. Those settings might not be there and you might have to go over and do everything again. But when you put it back in standby immediately, wait for 2 seconds, take it back to operating, all those settings save on the internal memory of the inverter. So that even if it goes off and you put it back on, it knows the settings and it knows how to operate. So we're basically done with the webinar at this point in time. I didn't touch the other steps because you would have to, you already know that you have to program the battery you're using, your grid interactive functionality, whether you want peak load shavings, whether you want some extra functionalities. I didn't dwell on those because I assume that you already know those extra settings that you must do to fully commission your system. This was just majorly for the multi-unit parts of commissioning the system. So thanks, and back to you, Alexandra.
Thank you for attending the webinar today. And to allow us to offer you the best possible webinars, we will be very grateful if you could take 2 minutes to give us your feedback on this session. Thank you very much, and we look forward to seeing you in the next webinar session.
Thanks, everyone. Bye.